When we think of AI, what comes to mind? Probably code, right? Data just kind of floating around in the cloud. But here's the thing, AI is intensely physical. It's real, and it's incredibly power hungry. So today, we're going to pull back the curtain and go inside these massive new factories. Factories built for one purpose, to generate intelligence itself.
Just look at this. This isn't some shot from a sci-fi movie. This is the real deal. It's a glimpse inside a modern AI data center. These are the humming, glowing hearts of the AI age. Huge, vast structures built on an industrial scale. And they're not building cars in there. Nope. They're building intelligence. So that brings us to this really central idea, right? If intelligence is now the product, what in the world does the factory that makes it actually look like? And you don't have to take my word for it. NVIDIA, which is, a massive player in this space, they don't pull any punches. They straight up call their latest technology the engine of the new industrial revolution. That's a huge claim. But when you see what this stuff can do, you kind of start to get it. Think about it. Every single time you ask a chatbot a question, or you generate an image, or get a recommendation for what to watch next, you're sending a request to one of these places. And we're not just talking about regular old server farms. These are purpose-built AI factories, and they are churning out insights, predictions, and creativity 24/7. Okay, so to really wrap our heads around this, we need to zoom in. Let's go from the big picture of the factory floor right down to the engine itself, the core supercomputer that's doing all the heavy lifting. At the heart of this factory is an engine with almost unimaginable power. So what kind of machine are we actually talking about here? Okay, get ready for this. It's the NVIDIA GB200 NVL72. And that description is so important. This isn't just a room full of computers, okay? This is an exascale supercomputer. That means it's capable of a billion calculations per second. And it's all crammed into a single liquid-cooled rack. It's got 72 powerhouse GPUs and 36 CPUs all working together like one massive, colossal brain. And the performance leap here, it's just staggering. Let's start with a number, 30. 30x. But 30 times what exactly? That's 30 times faster real-time AI inference. Now, inference sounds kind of technical, but all it really means is the moment the AI uses its training to do something, like answer your question. So a speed up this big means these models can handle way more complex requests in real time. It's why conversations with AI can feel so, instantaneous. But, raw speed is only half the story. There's another really crucial number here, 25 times. And that's 25 times more energy efficient. Look, these supercomputers drink up insane amounts of electricity, so making them more efficient isn't just nice, it's absolutely critical. This jump in performance per watt, it's a huge deal. It's what makes these AI factories even remotely sustainable or economically viable. But let's be real. A supercomputer, I don't care how powerful it is, it's basically just a very expensive metal box without one thing. A massive, and I mean massive, reliable supply of electricity. All right, so now we're going to zoom back out a bit. We've seen the engine. Now let's look at the factory's power backbone. This is the unseen superhighway, the thing that delivers all that raw energy needed to make the magic happen. And this is where a piece of serious industrial hardware called a high-power busbar comes into play. The best way to think of it is like the building's electrical skeleton. It's this modular system that's designed to do one thing, distribute enormous amounts of electrical current safely and efficiently to all of those very, very hungry server racks. And you can see exactly how they work right here. So on the left, you've got a single component. Think of it like one Lego brick. Then on the right, you can see how all those bricks snap together to create this complex building-wide grid. That modular design is absolutely essential when you're trying to design and scale facilities this massive. And let me tell you, these components have to be incredibly tough. I mean, data centers are pretty extreme environments. So this power backbone, it's built to handle it all. We're talking running at full power in scorching heat, resisting physical impacts, keeping out dust and water. Heck, they're even tested to withstand earthquakes. Because if this electrical skeleton fails, well, the entire AI factory just goes dark. End of story. Okay, so you've got the supercomputer, right? And you've got the power system. Now, how do you make them play nice together on such a ridiculous scale? Well, you definitely can't just show up with a hammer and start building. The answer is pretty wild. You build it twice. First, you build the whole thing as a digital blueprint. These factories are just so complex, with all these systems that depend on each other, that every single wire, every pipe, every bus bar has to be perfectly planned out and simulated in software, long before a single real-world bolt gets tightened. And this is what that digital construction actually looks like. Engineers use this highly specialized software to design the entire power network down to the millimeter, and then they merge it right into the building's architectural plans. The whole point is to find and fix any problems in the simulation, so there are absolutely no nasty surprises on the actual factory floor. Okay, so let's bring it all together now. Let's connect the two worlds we've been talking about, the computational brain and the electrical brawn. You know, it really is a perfect partnership when you think about it. On one side, you've got the brain, that NVIDIA supercomputer generating all the AI insights. And on the other, you've got the backbone, those heavy-duty bus bars, delivering the raw power it needs to even think. Each one is an engineering marvel in its own right, but here's the kicker. One is completely, totally useless without the other. So if there's one thing to take away from all this, it's this. These spectacular advances we're seeing in AI, they aren't just about clever software. They are fundamentally 100% dependent on the unseen, maybe unglamorous, but absolutely critical industrial-grade infrastructure that actually brings them to life. So hey, the next time you use an AI, just for a second, think past the screen. Picture those racks of liquid-cooled supercomputers. Picture that massive skeleton of high-power bus bars delivering gigawatts of power. Because as AI gets woven deeper and deeper into our world, the really big question is, what's it going to take, physically and electrically, to build the next generation of these AI factories?